In this problem, we are asked to sketch 2 cycles of the graph of y equal to the cosecant of 2x minus pi, making sure we label the x-intercepts and the locations of the asymptotes. We are ready to sketch this graph, and we can recognize that in order to sketch this graph, we could look at its reciprocal relationship of sine and sketch the graph for the sine of 2x minus pi. For the sine of 2x minus pi, we would recognize that the amplitude is equal to 1. Therefore, in our original function of cosecant, we know that our range is going to go between negative infinity and negative 1, or 1 to infinity. Our period for both the sine and cosecant are the same. Our period is given by 2 pi over b, which is pi units in length. Therefore, we know that our asymptotes will be at that our cycle will go through every pi over 2 units would be one of our cycle going up and one of our cycle going down. Our phase shift is given by the opposite of c over b, which is pi over 2, making sense that our graph was shifted to the right. Our 1 cycle interval for sine can be given by solving the following inequality. If we add pi to both sides and divide by 2, we'll get that 1 cycle interval for both sine and cosecant to go between pi over 2 and 3 pi over 2. We are now ready to sketch sine, and then we will sketch its reciprocal or cosecant. Since we're asked to do 2 full cycles, I have labeled my function axes from negative 3 pi over 2 to positive 3 pi over 2. We will first graph the sine function in our 1 cycle interval between pi over 2 and 3 pi over 2. For sine, we know that it takes on its average value at the start and stop of that interval, and then halfway through that interval. We know that since a is a positive 1, that it's going to make 1 full cycle starting from its average value, halfway between hitting its maximum value, back to its average value, down to its minimum and up again. We can continue this process that we know that it's going to hit its next cycle, which would be pi units in length, from pi over 2 to negative pi over 2. Therefore, at negative pi over 2, it also will be at its x-intercept, or the average value, also at 0. So we would sketch our graph in the following manner. We will now see the location of all of our x-intercepts for the cosecant function. We can then sketch each of the branches of those cosecant functions. The last thing we want to do is just to find all the x-intercepts, which there are none, and all the asymptotes. The asymptotes happen at starting at 0 and going every pi over 2 units. So our asymptotes would be at n pi divided by 2, for n being an integer.